All right, so this video we're going to do a optimization problem. We're going to do this number 10 right here. It says find a point on the line y equals 5x plus 4 that is closest to the origin. So obviously what we're trying to optimize is the distance from this point to the origin. So I've clipped this question over into my notes here. And I've actually graphed also the line y equals f of x so that we can have a picture of what it is that we're looking at. So here's the axis, and of course there's the line right there. It's a slope of 5, intersects the y-axis at 4, and here's the origin, okay? And so if we just, maybe I'll just zoom in here on that so we can, okay, so here's the origin. Now the point that's going to be closest to the origin on this line is going to be somewhere around here. So we have an idea, you know, it's going to be somewhere around here. How can we find that point? Okay, so yeah, if we just kind of sketch that out here real quick, let's see. So, ooh, nice yellow there. I don't know if that's so nice, but okay. So let's just say here's our line. Okay, there's y equals 4. And the point that we're looking for is right here, closest to the origin, right here. So somewhere around there, okay? But how do we do this? We got to set up an equation, right, that represents the distance between 2 points. So the distance between 2 points, okay, if you think about this, and one is the origin, okay, I want to find out, so really here's the origin, and here's the point on the line. And so I have a right triangle actually set up here, and I'm looking for the hypotenuse. That's the length. And so of course this is the x variable, this is the y variable. And so what I have is I have the distance squared equals x squared plus y squared. So using Pythagoras there, you see that? And so, you know, being that this is the origin, that's makes things handy. If this wasn't the origin, if you just had 2 points in space somewhere, and then what you would do is you would, you know, this is the triangle here, and you're trying to find this spot, and so you would go, you know, x1 minus x2 all squared plus y1 minus y2 all squared, and so on, equals distance squared. So you would have to include both points in this part right here, but that's for another question. Okay, so what you'll see here is that this one's pretty straightforward. So let's get back, okay, back here. So the distance here is what we're trying to minimize, and actually this is distance squared, which you'll find, you know, maybe later you'll run into this, but you can actually minimize the square of the distance. That's going to give you the same, the smallest distance as well. But let's just, for simplicity's sake, remember that we're trying to find the distance. So that actually is this. So let's just go with this, because that's what in the introductory course you'll probably, you know, want to do. So change this to d, distance. Okay. Let's see, what else do we, well, we have 2 variables. Remember, we don't want 2 variables. So how can I write this in terms of just one of those variables? Well, you're actually given the rest of the information right here in the question. Y actually equals 5x plus 4. You see that? And so really, distance here now equals the square root of x squared plus 5x plus 4 squared. And so now I have the distance function really, you know, in terms of x. So we'll simplify that a little bit here. D of x equals the square root of x squared plus 25x squared plus 40x plus 16. Okay, and so we have 26x squared plus 40x plus 16. All right, and you know, now can we take the can we take the derivative of that? As long as I did that right, say it's 5 squared, 4 squared. Okay. So you take the derivative of that, and of course this root sign is like a 1/2, right? That's the same as to the power of 1/2. If we reconsider that. And so the derivative is 1/2 times what's inside, just leave it alone. And then we subtract 1, so it becomes negative 1/2. Then you have to multiply by the derivative of the inside, remember chain rule. So what's that? Well, this is now 52x plus 40. Okay, see that? All right. So let's simplify that a little bit. Well, 1/2, if I multiply 1/2 by this factor, let's just do that. That becomes 26x plus 20, and then over, this is a negative, so that's over square root of 26x squared plus 40x plus 16. Okay? So why would I do that? Well, because we're going to let this derivative equal 0, right? And so if I'm going to let it equal 0, I don't really care what's in the denominator. As long as I don't accept an answer that is a restricted value, it doesn't matter what the denominator is. It can be any number at all, as long as the top, the numerator, is 0. So when I let this equal 0, let's just now let the derivative equal 0, I basically can forget about this on the bottom and just focus on the numerator equaling 0. And so that's going to be what? 26x equals negative 20, x equals negative 20 over 26, and that's going to be x equals what? Negative 10 over 13. Okay, so that's what we get when we let that equal 0. So if I get x equals a negative number, remember we are talking about distance, but you can't just simply reject this number because it's negative, because remember this number gives us the x value on the point, or on the line, sorry. So it gives us the x value right here. So remember, we needed an x equals a negative value, right? So the x value for this point is going to be negative 10 over 13. And now all I have to do is just look for the other point. And so simply, we put negative 10 over 13 into our original equation and we solve. So 5x plus 4. So y equals 5 times negative 10 over 13 plus 4. Okay, y is going to be negative 50 over 13. 4 times 13 is 40, 52. So plus 52 over 13. And y is then going to be equal to, that is right, 2 over 13. So the point on the line that is closest, and we'll bring up that, let's turn that on. So the point on the line that's closest is going to be have the coordinates negative 10 over 13 up 2 over 13. So let's just give that a quick test here. Let's just say I'm going to plug in a value, and I'm going to do negative 10 divided by 13. I'm going to hit enter. Does that look like the point that's closest to the origin there? Does it look like this is going to make a 90-degree angle here with the line connecting? Yeah, it looks pretty good, right? So that looks like we've done things correctly there. And so anyways, with that, here's your x and y value. So you can finish that off with a sentence. The point that is closest to the origin is, and you just list it, negative 10 over 13 and 2 over 13. And there you have it, with, of course, English or some recognizable language right there. Word sentence, there's your answer. And that is close to the origin. Again, we've checked for its reasonableness on the graphing calculator. And yeah, the math is sound. So that's number 10 right there.